So we'll cover these topics today. Brief a little bit about me because, let's be honest, who cares? It's supposed to have that in there. We'll start off a little bit by talking a bit about it. How do you access Neo4j and what kind of scenarios? Because that's an important fundamental as we talk about in what scenarios you want to use a stored procedure. That's sort of foundational information. So we'll go through that initially. And then we'll run into what is a stored procedure, why do you use it, when should you use it, and so forth. And we'll give you some examples. We'll show you some timings of things running pre and post stored procedure and so on. And we'll even cover a little bit about how to build your own stored procedures. So the idea being, you should come away from this talk sort of understanding this new functionality that was made available in Neo 3.0, when to use it generally speaking, and have a good start on being able to build your own. Good, we got rid of the statement about these slides, even better. So let's talk about how we deploy Neo4j. There's two primary ways you can deploy it. You can deploy it either in embedded mode, I love the green laser pointer, or standalone. The difference is in embedded mode, Neo actually runs in process with your Java application. So it runs inside the same VM. Personally, I'm a huge fan of embedded mode. It's really easy to run, it's really fast and easy to set up and use. And as you see, the difference there is when you're running embedded mode, you can talk directly to the Java API. It's right in process. It's a fantastic way to do things. The one drawback is it's really hard to deal with if you need to set up an HA configuration. Not impossible, but really hard to deal with. But if you don't need that, it's a great choice, and I actually started out building our app in that until I realized we have an HA problem. So then you get to standalone, which is, as far as Neo is concerned, this is the default way to install the server. So Neo now runs with a separate process and a separate JVM for your application. And then you have two options how you want to talk to Neo. You can talk to it via REST, there's a set of REST APIs, or you can talk to it via the new Bolt drivers. So those are the native binary drivers that Neo developed for talking to the database, and there are drivers in really all the primary languages. So in most deployments, standalone is considered preferred by Neo, and I would say by myself as well, assuming you do at some point think you might have to go beyond a single cluster. So let's talk then about how you actually get to Neo, and this is pretty fundamental, right? So I kind of created this little stack here. And so you have REST and you have Bolt, right? So those are two ways of getting to Neo. We saw before. Those are both available in standalone mode. Wouldn't make any sense, right, to send a REST call to your own VM and embedded. I guess you could do it, but it's kind of bizarre. So those are really primarily available in standalone. So that's how you should get to the database in your standalone. Then you can, if you want, either through the REST or through Bolt, you can execute CYPHER. Or in embedded, you can also directly execute CYPHER against the database, right? And CYPHER is great because it's very, very accessible. It's extremely expressive. However, it's not really as fast as Java. Essentially, CYPHER does get translated into Java more or less after you run it anyway. So underneath the CYPHER language API is a Java. It's a native Java API. And that is only accessible, as you can see, when you're running embedded. If you're running in standalone, you can't get to Java from Bolt or REST directly. Okay? So we're going to address that. So what is a stored procedure, right? Almost all major databases have some sort of support for stored procedure. Not all, most. Right? And fundamentally, all a stored procedure is some bit of application code that runs actually inside the database, typically, again, for performing database operations, reads, creates, updates, deletes. I mean, there's a whole group of people I've seen who've actually written entire applications in Oracle and just in stored procedures. It's not really what they're there for, but in theory, you can do that. Really, they're there to manage the database. And Neo is great because, again, you can have now access directly to that Java API. Remember before, couldn't get to the Java API when you were in standalone. Stored procedure, you're running inside the database. Now instead of embedding the database in your application, you've got essentially little bits of your application code embedded in the database. So you can get to the Java API. So Neo4j does ship with a couple of stored procedures right out of the box in 3. They're useful. They're mostly things that are there for monitoring and management. So listing out all the schemas, listing out the indexes, your constraints and things. It's about 5 or 6 it ships with. They're not super exciting, but they are there and they're useful, and it's a good way to get started with them. So there is APOC. I did promise I would talk about APOC. So here it is. APOC's, just put it in. Awesome procedures for Neo4j. So it's an open source, community contributed library. It's got a huge array of different stored procedures. There actually was a talk earlier, unfortunately. I've got to promote it, but I should go back in time. Hopefully you saw this talk. And they do have a booth, I believe that as well. So if you're interested in APOC, I would definitely stop by their booth. But there's lots and lots and lots of really good stored procedures in there. Mostly came originally out of some of Michael Hunger's work in taking things he had done before and seen done in the community, and then finding a standard way to do them, publishing them, making them available to everybody. So again, things from importing and exporting data to warming up the database. That's kind of a cool one. The warm-up feature actually will go and hit every node in your graph, so you can warm up your caches. That can be really cool. Some graph refactoring, indexes, new support for triggers. There's actually even really a cool time to live operation there that I just discovered yesterday. So you can actually say, hey, this node should live for 2 weeks. After that, you'll need it. Really cool. So lots of functions. The documentation is really quite good. You should check those out. So how do you install stored procedures? So maybe you want to use APOC and you want to install some procedures. How do you do that? It's really quite simple. Go ahead and grab the jar or build the jar. So you can, with APOC, you can either build it yourself or you can go ahead and download the files. If you're writing your own stored procedures, you'll be building a jar file, and we'll talk about that towards the end of the presentation. Then all you have to do is take that jar file or files, drop them into the Neo plugins directory, which is located directly underneath the top level Neo installation, and then restart Neo. That's it. It'll start up. Now, did I do something strange? Yes? Yes, if it's running in a cluster, yes. Family question. If you are running in a cluster, you do want to have all your procedures installed in every node. If you don't, strange and unusual things are likely to happen that won't make you happy. Yes? So the question was, is it the same as an unmanaged extension? The answer is no. It's actually a little bit different. It's similar, but it's a bit different, in my opinion. They're much easier to deal with and write than unmanaged extension. And unmanaged extensions, for the most part, too, like to talk about, like to automatically expose themselves via REST, right? Whereas Neo are directly available via CYPHER. Okay, great. So you restart Neo, and then you can verify your stored procedures. You can verify your stored procedures are there by calling this CYPHER function, call dbms.procedures. I'll screenshot of that in a moment. One thing to be aware of, if you're writing your own stored procedure and you mess it up pretty badly, which I've done a lot, you do something simple, and we'll get at this at the end again. It is possible Neo won't start. So if you made your own stored procedure and you deploy it, and you go and you trigger the console and it doesn't go anywhere, go look at the Neo logs. Probably an error that does something silly in your stored procedure, and it won't start. Start in the back.
Yeah, is there any measure of goodness, quality, maturity of the APOC procedures?
Yeah, so I don't think there's any objective measure. Again, most of the foundational ones at least came out of Michael Hunger's work. He's done a lot of seminal work for Neo for many, many years. It is like everything else, a community reviewed process. They're not perfect, but they're pretty good. I would say. I've been using them pretty successfully now for a number of different things. So let's see what this looks like. So how do we call stored procedures? New syntax in CYPHER as a 3L. Right? The syntax basically is the keyword is call, and then the procedure name, and then optionally any parameters that are in here. On the bottom there is the reference back to the documentation for the call functionality in CYPHER. So let's look at that. So if you actually do the call dbms.procedures, Here's a snapshot. It is a little blurry on here, sorry. But so here is a database with a bunch of the APOC jars, the library installed. So they're listed alphabetically. So you see on the left is the name, on the right is the signature, and with 3.1 you will actually get a description as well. So 3.1 is now in beta. You will get a third column, which is a description, which is really handy. So you don't have to kind of look at here and then go back to the docs somewhere to figure out what does that thing really actually do. So, talk a little bit about generally what a stored procedure is, how to get one up and running, and sort of verify that they're there. So, why would you use one? Like, what's the point? We've got CYPHER, we've got Bull. What's the point, right? So the first general use case, right, is when you need the power of that Java API, and when you need to do things in batch. So let's dive into this. When might you need the Java API? CYPHER's great, right? Do we have a lot? I'm guessing do we have a lot of Java developers in the room? Maybe some. Yeah, most have. Okay, but it's probably CYPHER. People do in CYPHER. Probably more. Yeah, right. CYPHER's probably more successful than Java people, right? I've got a data scientist who works for me. Can't write a lick of Java. Look and write some really good CYPHER. But sometimes you do want the Java API. So CYPHER is very accessible. It's easy to use, but it's optimized for certain use cases. And it makes those use cases really, really easy. We'll see an example of one of those in a second. But by definition, if I have a language that's optimized for certain use cases, well, then others are hard. If they don't fall into those things I'm optimized for. And it's when you hit those cases that are hard, you don't necessarily want to use CYPHER. I'm not saying you can't, but it can often be less painful to not use CYPHER. So an example of that is what I call multi-grouping. We'll dive deeply into that in a moment. As well as controlling the order of path traversal, right? So, and look at that as well. But what I mean by that is, see, you write a CYPHER query statement, right? And you might have one big match or even a couple of matches. Neo takes that CYPHER, runs it through the query planner, typically through the cost-based planner, right? Unless you opt back into the goal-based planner, and it figures out where do I start walking the paths, and in what order do I walk the paths to sort of do what you want. You don't have any control over that. It's a declarative language that's out of your hands. And sometimes CYPHER's not going to do the optimal thing there. So we'll look at that. Also speed. The Java API is definitively faster than CYPHER. That's a lot of the things in here is, in my opinion, and good ways. That one's a fact. The Java API is faster than CYPHER. There's work being done at Neo to sort of change the architecture of that. But right now, it's definitely faster. It can be orders of magnitude faster depending upon the use case. And it just makes sense. Right? There's an intrinsic overhead to CYPHER. It has to be basically interpreted procedural language. It goes back into the Java API. There's intrinsic overhead. So let's look at grouping, right? Grouping is one of those use cases that CYPHER is really great at. Makes it super easy. Who here's had to do group by in SQL before, right? Not super fun, right? You can do it. As soon as it can get complicated really, really quickly. CYPHER, it's super easy. So if I want to know, if I have a bunch of customers in my graph, and I want to know how many customers of every single age do I have, I can just say match c.customer, return c.age, comma count to age. And CYPHER just knows that I want to group those things. It understands, oh, you've got the age and the count of the age and the semi-working laser pointer. There we go. You must want to group those things together. And it just doesn't. And that's great, because that's a very typical use case, right? So if you run that, before I give you some metrics, I promised metrics in this too. I can tell you a little bit about the environment I'm running this in to provide these metrics to you. These are not benchmarks. These are just metrics to give you examples. This is running on a Neo4j instance. It is running on an HA cluster. This particular database has just under 7 million unique customer nodes. There's other stuff in there as well, but my example is primarily deal with customers. And I'm going to look at a week's worth of time for my example, and that is about 760,000 customer nodes. The reason I give you this is because Neo is honestly so fast that when I started doing this and showing examples with like a small sample database, the numbers were so close it seemed stupid, right? Like, why? Oh, you gain 0.2 of a hundredth of a second. Like, who cares? you need a big, a reasonable sized database to actually show you the differences. And it looks more like what production is like. So, back to customer rating. So, query is actually a little bit more complex than I said. Don't have to worry about that. But basically, again, you get to the end. I'm finding customers that made a transaction at a store within a certain date range. That's a week. And I'm returning their distinct age and their counts. So there's some output, right? It's not ordered, and you can see like I've got people at 92, and I've got people that are 50, and there's like 800 of them, and it's really fast. 15.7 seconds. That's after running a couple times, so I have some warm caches. That's pretty fast. 760,000 customers. I can get their ages and their counts and group it in 15 seconds. That's good. I like that. Right? That's a great use case for CYPHER. But we put out a retail application, and it's great to know your customers' ages. But I also want to maybe know their ethnicity, and I want to know their gender too for all my customers. So let's group by that. Right? Let's just go and do what we did before. And what sort of happens there? It might not be what you expect, though. So this is basically the exact. This is the exact same. So I pasted the wrong query. This is the exact same query. So pretend in your mind, right, that it says return distinct c.age, count c.age, comma c.ethnicity, count c.ethnicity. And then that would be the same query. And I get results back. Like, that's good. But if we look at them, it seems a little odd. Like my counts, so my ages and my counts, they don't quite line up. Like I can see they're not right. Like I have one person who's 15, and wait, I got another person who's 15. This isn't what I'm expecting. This is not what I want. This is not like how many of my customers are male and how many are female and how many are Caucasian. This is something different. Does anybody know what actually happened here? The results are right, not what I wanted, but they are correct. Does anybody know what CYPHER is actually doing here? I stretching it. So, right, for all three, right? So it's grouping by the unique combination of ethnicity, age, which might be interesting in certain use cases. It's not what I want, but it's kind of interesting. So as it turns out, it's not what I wanted. CYPHER doesn't work that way. Some of those cases where CYPHER makes it really easy for you to group by one thing, but you can't group by two, unless you want this scenario, which is not typically what you want. So you can, of course, just run three queries. I could count age, and I could count gender, and I could count ethnicity. Well, the problem was, right, if the one took 15 seconds and I run 3, I'm probably like 45 seconds now. That's too long. It's too long. So, it would be multiple, it would be slow. So this is a great use case for short procedure, right? We're in that area where this is a case that CYPHER doesn't really do what we want easily. If I want CYPHER to do what I want, it's going to be slow. We don't like slow. Nobody likes slow. So here's a short procedure. Blah, blah, blah stuff, right? So you see I got a call keyword. This is my name, my store procedure is common, FACTGEM, aggregate properties. I'm going to show you a couple different ways you can do this. One, I'm passing in the query. I'm passing in the query to get me to customers. So that's the same query that was there before, so now I'm returning customers. And this particular store procedure I wrote, I can give it a list of properties off of that customer that I want to do the aggregation on my stuff. Right? So I want age, ethnicity, and gender. So you see there's my result. It looks now much more like what I expect, right? The groupings look right. That's what I actually wanted. And this only takes 19.8 seconds. So remember, it took 15 seconds just for CYPHER to give me the count of unique customer ages. I've got 3 properties on that now. I can do it in 19 seconds. And adding a 4th property or a 5th, it's really not going to change that time at all. So I'm only walking the minimum once. Okay. So classic case for a stored procedure, doing something that CYPHER just doesn't natively let you do. So there's another way we can call stored procedures. I'm not going to exhaustively hit on all the stored procedure syntax. That's why I gave you the reference, why this is an introduction. So instead, I can use a stored procedure inline in my CYPHER, which is a very cool way to do it. So here I have my CYPHER, my match, blah, 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 blah stuff, right, with distinct C is customer. And then I say call column factor, and anchor properties, and they pass in those actual customer nodes, right? So I did a minute ago, I took that whole sort of text and I added the store procedure, and that's kind of awkward and maybe not the best way to do it. Better way to do it probably, use it directly inline with my cipher, it makes it much more accessible, and I can actually pass those nodes in as a parameter to the store procedure, and this will run again right out of the, the shell or the cipher web console. Okay, so let's talk complex path walking. And I'm gonna try not to lose even myself in this one, because it gets a little weird. Let's talk about, so let me give you a scenario. This is a model. So in my sample database, I have customers. Customers make transactions. Transactions have line items. I think about when you get a receipt, right? So the receipt is your transaction. It's got an ID. Every line on it for what you bought is a line item, and it is for a product. And in my case, a product might have a style and a category, for example. Okay. And what I want to do is basket analysis. This doesn't sound like it's too hard, right? But here's an instantiation of that. Very simple one, right? I have one transaction, and it has 3 different line items, which have 3 different products and 3 different categories and styles. And a typical retail use case is you want to do what's called basket analysis, right? It sounds very simple. The idea is, I want to know people came in and they bought laser pointers. What did you buy with the laser pointer? Did you buy batteries with it? Okay, that makes sense. Did you buy something else? I want to understand that so I can better manage my retail business. And at first it sounds like it's a pretty simple thing to do. What you essentially want to do is you define the thing you're looking for, your item of interest. So in this case, I want to find things in a certain style and category. So maybe the category is laser pointer and the style is green. So I want to find everything that has that. And then I need to find everything else in that transaction that is not that. I need to gather up their style and their category to identify it. So, remote control wireless, for example. And then I need to get costing information. Because I need to know how much everything cost in my basket. So I didn't have to go back up to my line items only for the things that didn't match. Oh, and by the way, I've got to count all my transactions and count how many times things matched and how many things didn't match, so I can do some math on that to do some basket analysis computation. It doesn't sound that bad, right? But you can also have multiple filters, and in reality, you can say, like, I want to find everything that is by style and category, say, so laser pointer green, I want to know what size of things about that. It seems a little odd, but retail companies do this, so you can compare different axes. Okay, well, you can do that in CYPHER. I know because we did it. It was hard. A lot of you out there are probably better at CYPHER than I am, and it wouldn't be as hard for you, and that's fine. It was not an easy query to write. And the performance was not good. It's not good for right now. This was the query initially. Yes, you can't possibly read it at the point, right? You see several different match clauses, and then there's some joins, and it could probably be optimized. That's fine. But it's a big query, especially CYPHER, right? You don't get a lot of really big CYPHER queries, very expressive. It's a fairly large CYPHER query. And then there's some math and some counting and something that goes on. And it's nice though, because it does allow us to generate stuff like this. Sorry, I have to block out a lot of stuff because it's real customer data and I can't show that to you. But so you can see what this is basically generating. So what a basket analysis typically looks like, and you have what it is I'm matching and what was paired with it, and you can do math and show circles and things, and give lift and confidence and so on. So it's a really important query. It's really impactful for customers. The problem was, with 79,000 transactions, it ran for over 3 minutes. Sometimes, depending on size, it ran for a lot more than 3 minutes. Like, go get some coffee, meet a new friend, have some more coffee, come back, and maybe do some basket analysis. And the reason is, we're not controlling how it walks the path, right? The problem is, if we dance back real quick to this, there's a scenario where you can tell CYPHER to match, you can match your transactions, and you have to sort of match different things, but then you have to kind of go back up your path, right? So you come down, and then you have to go back up, and you come down, and you go back up, and you go to the side, and you have no control how CYPHER's doing that. And so it walks a lot of extra things. It might walk this 2 or 3 times for every single product that's in your thing. And if you've got 79,000 transactions, that's way more than 79,000 line items. It's a lot of work for the database to do. So CYPHER wasn't good. So we wrote a stored procedure. Stored procedure runs in less than a second. That we like. That's a big one. And actually, the stored procedure actually is more work than the CYPHER one because it's actually more complicated. It takes more variables into account. But the reason why it runs faster again is I can use the Java API to only walk each path once. I can keep track internally of where I've been, what I'm counting, what I'm matching, only walk down the path once. That's a huge difference sometimes, right? So again, this is a case where the complexity of the path walking, you can't control how it does it in CYPHER. You need to gain control over it for performance. Great use case for a stored procedure. So let's talk about how do I create a stored procedure. More references, right? Because I'm going to give you an overview. And before I even go this, as a quick sort of side note, so we're going to can time, mention batch processes, another great reason for using a stored procedure, right? So if you have to do a lot of inserts maybe all at once, say I want to insert 15,000 nodes, you can make 15,000 calls over REST, but every time you do that, you have the overhead of creating the connection, sending it over the wire. It's not that fast. Instead, it's much faster if you can take 15,000 parameters, send them all over the wire at once to a stored procedure that then loops through them and does your creates. Or again, if you want to run a bunch of searches and finds, it's the same kind of thing. Do things in batch. And there's a lot of things in APOC actually that are built just for that to do things in batch for you. This is a classic use case for a stored procedure. So how do you create your own? Right? There's the real fun. Let's do it. Let's start real simple. I like simple. Create a public class. It's got to be public. So I like graph connect demo class. Then you have to inject some resources. Right? So this is using standard Java EE dependency injection with our at context annotation. These are the three primary things that you can inject into your stored procedure. The graph database service, this is the thing you're primarily going to use. 9 times out of 10, this is your go-to guy. This is essentially your handle to the Java API. If you've used that before, you're familiar with this. This is what's going to let you execute your queries. If you want to start getting fancy and do some different things, you have the graph database API. That will let you do things like if you need to do periodic commits and control your own transaction, you'll need to use that guy. If you're doing schema operations, but yeah, you can do that. So, side note, I suppose, be aware that when you're calling your stored procedure, okay, you have to you call them by a CYPHER query, right? And to execute a CYPHER query, you have to be inside a transaction, right? That transaction, right? Can't execute CYPHER without a transaction. So when you get into the stored procedure, what you're going to do, you're running inside the caller's transaction. Okay? Just keep that in mind as you think about how you want to write your stored procedures. You're running in your caller's transactions. There are ways to manage that on your own. That's over here. We're not going to go into that in this introductory talk, but that is a major use case for having to do with the graph database API. And there's log. So if you want to log stuff, that's your handle to write things to the Neo4j server log or the debug log, depending on what log level you use. Super useful, obviously, for debugging or errors. So you've injected some resources. Now you need to annotate your procedure so that Neo knows this is actually a stored procedure and can make it available. So app procedure is how we do that. And then you go ahead and give it a name. There isn't sort of a standard way of doing that right now. There's no standard convention for a namespace thing. There is a discussion going on about that inside of Neo and the APOC community. So feel free to participate in that. I use sort of the standard Java type reverse DNS thing because I'm old, I guess. So other way of deploying a method, so option 2, you can say performs writes. So if your procedure is not going to just query, but is going to update or delete or create a relationship, you need to say at perform writes. If you don't, Neo is going to yell at you when you call him. It's going to say, you cannot perform a write because you did not annotate that way. So Neo needs to know this so it knows how to manage your transaction. With 3.1, there will be an additional annotation that comes available, which is I think at DBMS, and it's basically there to say I'm actually going to do database management stuff like mess with my indexes or something like that. That's actually incredibly hard to do prior to 3.1 in a stored procedure. So then you do stuff, right? So then the housekeeping, then you actually do the stuff you want to do. So here's something like stupidly simple, not a good example for when you want to store a procedure. This just counts all of the stuff in my database. So we use our handler to the graph database service. We call execute on it. We pass in a CYPHER query. We get back our count. And then we have this little weirdness at the end, right? Return stream of count. So all of your stored procedures they can be void, so you can return nothing, that's okay. And if you don't, then you have to return a stream of something. Okay, so stream is something that came about in Java 8. Java 8 is required for Neo 8, for Neo 3.0 and procedures. There's a link there to a really good article that explains to you what Java streams are and how to use them and so on. It's really not that complicated, but it's sort of outside the scope of this talk. But so, suffice to say that this works like a long, I can say stream of long, and that is acceptable. There are limitations, though, on what you can return from the stored procedure. These will bite you, even though you read this, trust me, because I've had it happen a bunch of times. So I've quoted from part of the Java doc linked below. You must always return a stream of records as a class with only public, non-final fields. That's the emphasis is mine. So if you create a class and you've got maybe you want to have a couple properties in it, and one you're going to use internally maybe for some metric, no good. It will forgive you an error when you call it. Every field must be declared public. It has to do with how they are serializing the results back over the wire. Everything must be public. So here's a class that we actually use ourselves. This is what I call basket analysis result. It's what comes out of that basket analysis stored procedure I showed you before to allow the UI to generate that nice picture. And I basically have a bunch of maps of things. Notice they are all public. This is a valid return. If I were to get rid of those publics on either any one of them, no longer valid, Neo is going to get angry. Just copied out of the Java docs. These are all the valid return types. So basically your primitives, sort of what I would call the Neo primitives, right? Nodes, paths, and relationships. And then basically maps and lists and anything that, again, is in a class and has public fields to it. And that, I think that's for the 5-minute mark. Time to any more questions. Sir? Yeah, absolutely. So the question was, is there any way I can take the values from stored procedures and use them inside the CYPHER query? Absolutely. So there's I gave you a very brief look at the call syntax. There's also a syntax that says call stored procedure and then yield. And then you yield so let me go back to this. So let's even go back to my real simple one. So here I'm returning count. I'm returning it as count. You have to actually, so you yield the name of the thing that's actually coming back. So in my class, for example, I could yield units sold, right? The names have to match, like that matters, right? So you think it does, no it does. So I say yield, call the aggregation, yields units sold as units sold, and I can take that and use it right in line within the CYPHER query. Yeah, that's actually a very, very useful scenario. Yep, anything from there, and actually that's going to get easier to in Neo 3.1 as well. That's been enhanced. Yeah. So, and I would refer you back to that call section.
Thank you. If there's already existing stored procedures, can they be migrated and then changed for the syntax to CYPHER easily? Or is it a tedious one?
So I'm not going to tell you. So you have existing stored procedures, and you want to migrate them to what? So you're using Neo stored procedures?
No.
Ah.
You are building this.
Oh, you don't migrate CYPHER to store. Sorry, okay. Right. So if you want, you have to use CYPHER. Can you migrate it to store procedure? So yes and no. As I showed many times, you can just run CYPHER inside a stored procedure. Typically, not that easy. I say typically because in case like batch snares again. If when I'm doing my stored procedures, I want to do like batches and things. Perfectly great to write CYPHER. I've got some functions that take a whole bunch of information, for example, and then use CYPHER to batch insert them all at once. Works great. For other things, like typically you're going to use the Java API because that's where you can get the speed. But yeah, absolutely, you can run CYPHER in there. You're doing a combination of CYPHER and the Java API, so like the aggregation function I showed you. If we look inside the stored procedure, we use CYPHER to get the first transactions because that's really fast. And then we just use the Java API to manage the walking of the paths after that.
Exceptions treated the same as a try?
Yeah, exceptions. Yeah. So essentially, inside the stored procedure, if you want the exception to actually propagate, right? So I want the client error, I want the client to get the error. You must throw a runtime exception. It must be an exception that subclasses runtime. Otherwise, it just stays over there. So if you throw an exception and you don't catch it, and it's not a runtime, like you'll get an error in your Neo debug log, but you'll get some strange error in the call where probably related to like the protocol being cut off and not being a response you expected. It won't look right. So yeah, catch the error, log out if you need to, and then rethrow something that extends runtime exception. Okay.
Yeah. So at the beginning of the section, you mentioned that you also face some issues writing procedures in the Neo4j startup. So like are those exceptions or like what can you see some examples?
Sure.
Of what are those?
Classic one, you screw up your stored procedure name. So I've written one stored procedure. I'm just going to copy it and I'm going to paste it over here and I'm going to change it. And I forget to change the name, so I've got two procedures with the same name. And here goes, oh, no. So it's stuff like that. Now, actually, again, in 3.1, there is, I believe, a new APOC procedure coming out that will give you actual compile time, essentially, errors, so you don't have to go and actually compile and then deploy your C base and still make a mistake. So typically, it's not starting, it's you didn't annotate right, or parameters that come in, you need a name annotation, you didn't give them a name annotation. So it's those type of things. Yeah. And there is a whole nice unit testing framework explained in the docs for actually doing unit testing of CYPHER that you can use the in-memory data, the in-memory temp database for testing would be very useful.
Last question. Hi. Thanks for the presentation.
Thank you.
If you're already using unmanaged expansion, would you migrate that to be stored procedure? And is there any things you cannot migrate or any gotcha to know when you're trying to go through an exercise?
Yeah, so personally, I was never a huge fan of unmanaged extension. That's just me. I don't really love that. That's just me. Okay. So I haven't done a ton. But yes, you can. I would migrate because again, the unmanaged just came before stored procedures. They really targeted at the REST API. If you want to do REST, then great. You can do that, although stored procedures are available via REST as well because of the CYPHER call. The biggest gotcha in 3.0 is you can't, it's very hard, let's just say, not impossible, very hard to do any kind of database management operations, like if you want to mess with the indexes in any way. It's not undoable. If you look at APOC, you'll see APOC does do it, but there's a lot of flaming hoops of fire you have to jump in to do it. In 3.1, that becomes very easy again for the navigation. That's the only real gotcha. Other than that, everything is accessible. Thank you very much.